So we're going to do a gamma pivot example, specifically 9.2.8 in the textbook. Suppose that x1 to xn are IID exponential of lambda. Then our t is a summation of xi's, is a sufficient statistic for lambda, and t is distributed through gamma on the interval of to n to lambda. Now, in this problem, the gamma PDF of t and lambda appear together as t divided by lambda, and in the gamma distribution from n to lambda. The PDF is this, is a scale family, so that makes us solve this problem in a little different way. So keep in mind that our q of t right here of lambda is from this distribution. And if we can simplify that down, it is actually from gamma from n to 2. Thus, we get this, and that means our PDF of t, which can be written like this, is the following. And this is for some function g and some monotone function of q. Now, using our theorem 2.1.5, which is back way from the beginning from statistics 1, we can actually find the PDF of x using this little helpful trick, where the PDF of x is 1 over lambda with our exponential and our exponent right here of negative x divided by lambda. So in this case, it also, for that theorem, we need a y. So we already have this information, so we're going to let y equals this. Therefore, using this, we can simplify and keep going. Keep in mind our I right here is the square root of negative 1. Thus, we're going to take the interval from 0 to infinity, and we get e to the I tx times 1 over lambda with our e again, because we're just plugging this information in, because we know what our PDF is above. Now we're going to use basic math and simplify this, and even some little bit of calculus. Since that's a constant, right, that 1 over lambda, we can actually go ahead and pull that out. Then we're left with a lot of exponentials in there and e's, and we can use our exponential rules to actually simplify it further before even taking the integral. Thus, we get this. And we can't forget the dx back here. And continuing with our simplifying and everything, I see that my exponentials both of them have x's involved, so I can actually pull an x out. Now, whether you'd pull a negative x out or an x doesn't make a huge difference right now. It just depends on which kind you want to do. It just changes the sign inside with the exponents. Thus, I get this. And I'm going to take the integral, and I get my 1 on top since it's an exponential. And then I have my exponents below. Then I go ahead and multiply these two fractions. And it simplifies to get me this. And I can simplify even further to this. And since it's under 1, I can go ahead and put it with a negative 1 exponent instead of having it as a fraction. Now bringing in the y, we know we let the y be that summation of x of I. So I went ahead and plugged that right here for my y instead. Since we have the summation, we have it right here as well. Since I was able to pull that out a little bit, I still have the x to the I up here, which makes this right here inside the parentheses exactly as it was above. Therefore, I can go ahead and plug that, what the answer I got from above, into this spot. Thus, I get this. And we can even simplify it a little bit further. And I have the negative n right here as my exponent because of the n right here. Now this is just one piece of the puzzle to help us actually get our answer and to finish this problem. So thus this shows us if x is from the gamma distribution from 1 to lambda, then our t is going to equal the summation of x of I is going to be from the gamma distribution from n to lambda. Using this information, we can actually go ahead and find the PDF of t. It's kind of given to us. We're just plugging in some information since we know how to find the PDF of x there. Since it's a little complicated looking and there's like q and stuff in here, we're going to go ahead and use like kind of like a substitution to make it a little bit easier for us. I see that du equals 2t over lambda. I take the derivative of u, and I get 2 over lambda of dt. Thus, from this information and stuff, we can find the distribution on our x squared of 2n. So using what we know about gamma pivots, we have this c right here, and it's kind of like a plug and go kind of thing. Find out what my q is, and I can plug it in there. I don't have an a yet, but I know what my q is. Same with the b. I don't really know what it is yet, since it depends on the problem for the a and the b. But given what we know about our gamma pivot, that definitely, should equal 1 minus alpha. I actually took this right here inside my brackets, and I simplified because I wanted to see what lambda was by itself. Using basic algebra skills and everything, I got my lambda by itself. And I have the 2t divided by b on my left, and similarly on my right with an a though. Thus, this shows me that q, t to the lambda, is a pivot, but it's also independent to lambda, that it didn't really change it horribly much, but it's still a pivot. So we're actually going to continue the example from before. We had this. And we also had that equal 1 minus alpha because it's a gamma pivot. But if an example for a reason gives us what that a and that b is, we can actually kind of take it even a little bit further for that specific example. So in this case, let our n be 10. And let's say that we have a 95% confidence interval. So 95% in decimal form is 0.95, If I know that 1 minus alpha equals it, that means my alpha is 0.05. Just like that n squared, I want that alpha squared. Therefore, I take the square of that, I square it, and I get 0.025. So then when I plug in the information I know and what we had from before in the first part of this example, we get this. And this is just plugging that information in. Since my n is 10, the 2n is 20. That's why we have that 20 there. So I get 0.975. Similarly, that's how I get this 20 here, is from the 2n. 2 times 10 is 20. And I have my alpha squared here, which is 0.025. So it's like you can use some basic algebra to solve and rearrange things and find what my b is. So b for this, when I have my n of 10, is going to be this, and my a is this. Thus, again, now that I have this information, I go ahead and type this in the calculator and type it in, and I actually get b equals 34.37, and my a is 9.59. Thus, when I plug in the information, instead of just writing out 2t divided by a and 2t divided by b like we heard earlier in the last example, we can be a little bit more specific. So now that I know my a and my b, I can just plug it in. And this example is probably like a puzzle piece. You have all these different puzzle pieces and they have to go together and they mix till you see the picture and we get our answer. So this is a specific gamma pivot example that builds off our example from previously.